In this video, we are going to solve the spreadsheet question for the A-Level I.T October-November exams. The question begins with the source files you've been provided with. You will create a spreadsheet for a quantity surveyor to calculate the amount of concrete required for the foundations for a wall or building. You must use the most efficient method to solve each task. All documents produced must be of a professional standard and a suit in a business context. All costs must be displayed in dollars. And we've been given a conversion of 1 meter being 1,000 millimeters. Now, create a new spreadsheet that looks like this. So our first task is to recreate what we see over here in this image. So we are required to merge cells as shown, center align all cells in columns B and F. So they are giving us an idea of how to format cells or columns B and F. Now place your name, center number and candidate number in the merged cells E2 to G2. After which we are going to save our spreadsheet with the file name QSA underscore followed by a center number and then a candidate number. So let's begin by typing out the details required in the spreadsheet. Now let's continue with all the details that appear in column C, E, and G. We continue with formatting the details as required. So for our first row, I'm going to click and drag to column G and select merge and center. Let's increase the font size. Add a background color of black and change the font color to white. We can extend this further. And let's do the same for our second row where it says, what are you constructing? We are extending from column A to C. And we do a merge and center as well. Give it a black background and change the font color to white. We also need to bold the font and expand our columns. So for the other subheadings on the sheet, I'm just going to use the format painter. So I'm going to click what are you constructing? and double click on the format printer. Just click on anywhere I need to add that format. Now let's add the required alignments for the entire table. Now I'm increasing the row height of where the content is. And let's add borders as well. Now let's go ahead and save our work. So the file name is going to be QSA followed by your center number and candidate number. Next, let's examine the data files we've been provided with. So I've already opened both source files. One is for the sol type. We have the sol type represented here, and the width and the depth. We have some of the data represented by X, and it is showing us that X shows the soil is unsuitable for strip foundations. When we go into the next file for the climate, we have climate for region where building will take place. And we have the climate type and the frost factor. Now let's go ahead and import these two tables into our workbook. So I'm simply going to do this by just copying and pasting the entire content onto a new worksheet in our workbook that we first saved. So I'll add a new worksheet here. Let me rename this climate. And paste. I'll create another sheet and rename it soil. And I'll open my soil type table, copy, and paste. Next, let's format the frost factor data as percentage values. So we're going to climate, select the frost factor data, and click on this percentage sign. Alternatively, after selecting, right click, go to format cells, select percentage, reduce the decimal places to 0, and click OK. Now in the worksheet created in step 1, make sure that cells B3 and B4 can only contain a blank cell or the letter Y in upper or lower case. So back in our QSA worksheet, we select B3. You can hold down Control and select B4 as well. Then we go to the data tab at the top and select data validation. Then we go to settings. On the settings tab, drop down allow and select list. We are entering a list of characters. That's why we selected list. So we have capital Y or uppercase Y and small y. The question says we can allow blank spaces. So for that, we keep this checked, ignore blank. And make sure there's no drop down. So we need to untick this. Then we go to the input message tab and enter a message for the user to follow. So here we can type in enter y and small y. The question didn't ask us to add an error message, so we ignore that for now. So we click OK. In cell B6 and B7, make sure that users can select down from drop-down lists the cell type and climate type. Use the worksheets imported in step 2. So let's go ahead and select cell B6, which is the cell type. Then we go to data validation once again. Settings. This time we need a list. And it's going to be a drop down. And for the source, we click on this button here. And then we have this data validation window here. Then we go to our soil tab. And from the soil tab, we select the soil type names. When you're done, you close and you click OK. So when we drop down, we have all our soil type names here. And we repeat the process for climate type. Select cell B7, go to data validation. We select list, and from the source, we go to our climate tab and select the climate types here. Close and click OK. Enter a function in cell B14 to look up the width of the footing in meters. Use the soil data imported in step 2. So for this, we're going to use the vertical lookup. We click on cell B14, hit your equal sign and start typing VLOOKUP, and then hit the tab key. Click on FX up here. And for the lookup value, select soil type. For the table array, go to our soil worksheet and select the entire data. For column index, we need a width, so we are selecting column 2. And for the range lookup, since we need an exact value, we enter 0. And click OK. Initially, you have an NA here because we haven't selected any soil type. So when we come here and select any of the soil types, it gives us the width that goes with it. But the width should be in meters. And what we have here is in millimeters. So we need to convert that. So back in our QSA worksheet, with B14 selected, we come up here and add to the formula divided by 1000. Then we hit enter. So this is the correct value in meters. Next, we are to enter a function in cell B15 to look at the depth of the footing in the meters. Use the soil data imported in step 2. So let's click on cell B15. Start by typing in our VLOOKUP. Click the FX once again. And our lookup value once again is going to be the soil type. Table array. We select the data in the soil table. The column index this time around is going to be column 3. And the range lookup is 0. Click OK. And let's go ahead and select the soil type, limestone. So once again, we need to divide or convert this into meters. So we go back into our formula bar and divide by 1000. Next, we need to edit the formula placed in step 6 to increase the depth of the footing by the frost factor percentage. Use the climate data imported in step 2. And we've been given a formula: depth of footing equals value depending on soil type multiplied by 1 plus the frost factor percentage. So to obtain our depth of footing, we once again go into cell B15 and edit the formula that we have there. The depth showing here is the value depending on the soil type. So all we need to do is to double click and edit the formula to suit what is in the question. So I'm going to multiply, or bring the multiplication sign, open a bracket, 1 plus frost factor percentage. This we will need to look up. So I'm going to type in VLOOKUP, click on the tab key and click on the FX. And this time the lookup value is going to be the climate type. The table array, we go to our climate worksheet and select the data there. For the column index, since we are using the percentage, we are going to select column 2 or 2. For the range lookup, it's going to be 0. Then before we click OK, come to the formula bar and add another closing bracket to the end. And then we click OK. Now, if I select a climate type, it should give me the appropriate depth of footing based on the formula we've just edited. Next, we are to enter a formula in cell B16 to calculate the length of the footing in meters. Length of footing is equal to length of the wall plus width of the footing minus 0.1. For the length of the footing, we come down to cell B16 and enter the formula as required. So my equal sign, length of wall, that is B11, plus the width of the footing, which we have here, minus 0.1. Next, we need to enter a formula in cell B17 to calculate the volume of the footing rounded up to the nearest 0.1 meters cubed. And the formula has been given below as volume is equal to width times the depth times the length. So let's come down to our cell B17 and begin with our equal sign. So we have the width multiplied by the depth multiplied by the length. But the question requires that we round up our answer to the nearest 0.1 meters cubed. So the keyword there is round up. So you can double click once again on our formula, come to the beginning And you can start typing roundup. And at the end of the formula, bring a comma as the syntax requires and type in 1, close brackets, and enter. Next, we need to place the formula in cells F14 and F15 to copy the values from cells B14 and B15. So let's go to cell F14. Type in the equal sign and click on cell B14 and enter. And then we do the same for cell F15, equal sign, click on cell B15 once and enter. Enter a formula in cell F16 to calculate the length of the rectangular footing in meters. And we are given a formula as length of footing is equal to 2 times into brackets length of the building plus width of the building minus 0.4. So we head to cell F17, which represents the length of the footing. Begin with the equal sign. 2 multiplied by, we can open our brackets now, length of the building, which is F11, plus width of the building, which is F12, and then you bring your minus 0.4. Now we have to enter a formula in cell F17 to calculate the volume of the footing rounded up to the nearest 0.1 meters cubed. Now this is similar to what we did in step 9. So let's head into F17. Begin with the equal sign. We have our width multiplied by the depth, F15, multiplied by the length. And before we hit the enter sign, let's round it up. So we type our round up, tab key, and go to the end of the formula, 1, close bracket, and enter. Enter formula in cells B18 and F18 to calculate the cost of the concrete, rounded to and displayed to the nearest dollar. Concrete costs 124.3654 per cubic meter. So to enter a formula to calculate the concrete cost, we will need the volume, which we've already calculated here. So select cell B18, type your enter sign, click on the volume, that's B17, multiply by 124.3654, and then we enter. And then we do the same for this side. Equal sign, the volume, times 124.3654, and we enter. Yet we have to round our figures to the nearest dollar. So to do that, we are going to use the round function. So double click on cell B18 and just where the formula begins, type round, hit the tab key, and after the formula, we enter 0 because we don't want any decimal places at the end. Then we hit enter. Do the same thing for this side. Round, tab key, comma, 0, close bracket, enter. Next, we have to edit the formula placed in steps 5 to 13 so that if the soil is not suitable for strip foundations, appropriate messages are displayed in the cells. Now, before we go ahead and edit our formula, let's make a quick reference on the soil worksheet. Based on the data available, we have some of the soil types which are unsuitable for strip foundations, and their widths and depths are denoted with an X. So if we go back to our QSA worksheet and we select a soil type like chalk soft, we have an indication of value which simply denotes an error. So our task is simply to replace these with an error message. So beginning with this width, I'm going to double click to reveal the formula. Go to the beginning of the formula and type in the function if error. Now the value is our entire formula. Now we need to add a value if error, which is the message we are going to add. So I'm going to add a comma to the end, double quotation marks, and I type in the message unsuitable for strip foundations. Close it with a double quotation marks and bring your closing brackets. So I'm going to replicate the same function for all the cells that we have here. Place formula in your spreadsheet so that when the letter Y is placed in cell B3, the contents of cells in the range E8 to G18 are not visible. B4, the contents of cell in the range A8 to C18 are not visible. We are to save this spreadsheet as QSA1 followed by your center number and candidate number. So if we place the letter Y in B3 for freestanding wall, all the contents for rectangular buildings should not be visible. And vice versa, when I place the letter Y, denoting yes, in the building cell, that's B4, all the contents for freestanding brick wall should not be visible. To achieve this, we are going to use conditional formatting. So since we are going to do B3 first, we are first going to select this cell range for rectangular buildings, head up to conditional formatting, highlight cell rules, come down to more rules, and then we come down to use a formula to determine which cells to format. Now, format values where this formula is true. Click on this small arrow here, and then we select the cell B3. Then we add an equal sign, bring a double quotation, type in our Y, close it with a double quotation, and then you can close this window, come down to this format button, Let's go ahead and select the font color that will appear. In this case, we select white. We head to the border, select outline, and then we come to the fill. We select no fill. In so doing, all the black areas will not be visible. So we click OK on the format, and we click OK for the new formatting rule. Next, to test this out, we type Y in B3 and enter, and it all goes away. So let's go ahead and replicate the same procedure when we enter Y in cell B4. So we go ahead and select the cell range, head up to conditional formatting, more rules. Once again, use formula to determine which cells. Click on the little arrow and we select B4, equal sign, double quotations, Y. We close, head down to format. For the font color, we choose white, border, outline, and for the fill, no fill. Click OK here and click OK once again. Let's test it. So it worked. Next, let's go ahead and save our file as QSA1. So I'm just going to add a 1 here and save. Test your spreadsheet with the following test data. Save each test as a spreadsheet with the given file name followed by your center number and candidate number. A freestanding wall 12 meters long, built on gravel in a climate that is never frosty. So for our first test, we begin with a freestanding wall. So we enter Y for yes, which is 12 meters long. So we come to the length and change it to 12 meters. Built on gravel. So the soil type, we choose gravel. And that is never frosty. So the climate type, select never frosty. So with that, we go into file and select save as and change the file name to QSA2 followed by your center number and candidate number. A building 4 meters long and 3 meters wide, built on soft chalk in a climate that is never frosty. So with this, we begin by entering a Y for our building. The length of the building should be 4 meters and the width 3 meters. And it's built on soft chalk in a climate that is never frosty. So with this information, we go to File, Save As, and with this, we save it as QSA3, followed by a center number and candidate number. A building 4 meters long and 3 meters wide, built on granite in a climate that is never frosty. So based on our previous information, the only thing that has changed this time around is the soil type. So we drop down and select granite. And go to File and Save As and change the name to QSA4. A building 4 meters long and 3 meters wide, built on granite in a climate that is sometimes frosty. So once again, all we need to change here is the climate type. So we drop down and select sometimes frosty. Then we go to File and Save As and change the file name to QSA5 followed by your center number and candidate number. And lastly, there's a problem in the design of this spreadsheet. Identify this problem. Enter in cell A20 of QSA5 what the problem is and how you would resolve this problem. Note you do not have to correct the problem in your spreadsheet. Save the new spreadsheet as QSA6 followed by your center number and candidate number. To identify the problem, we can begin by entering Y in our data sheet where it says freestanding wall. So if I enter Y, this should appear, and if I enter Y for building, this is what is available. But what if I enter Y for both ends? You realize that everything goes away. So this is actually a problem, because if the user enters Y for both places, we are expected to have both sides still available. So in cell A20, we are going to write down the problem. So let's scroll up a bit and begin by typing in here. I'm going to increase the size or the height of this cell. Wrap the text in the cell. And then I can continue typing. So with this, we go to File and Save As. And we save this as QSA6 followed by your center number and candidate number. And with that, we've come to the end of this video. I hope you enjoyed and understood my first tutorial on spreadsheets. You can leave your views and suggestions in the comment section, and I'll do my best to respond to them. And remember to like and subscribe if you haven't done so yet. Until we meet in the next tutorial, it's bye.